Hi, everyone. My name is Chris Wise. I'm a Solutions Architect Manager with the Aerospace and Satellite team, and I'm joined by Joy Fosnacht, who is one of our Principal Solutions Architects. And just a real quick question, is everybody having a wonderful 2024 Generative AI Conference? AKA reInvent, right? So, what we're going to focus on today is specifically around prompt engineering. So when you're doing image analysis, understanding how you structure your prompts is going to be super important. We're going to look at Bedrock and how Bedrock can help you to uncover those better insights into image analysis. Joy's going to run us through a demo to kind of show some of these image analysis and how you get these better results so you can use them in your business. And then finally, we'll take some questions if we have time, but if not, we will stand to the side over there and would love to talk to you after the fact. So prompt engineering, right? This is often a topic that we don't really dive super deep in when we're talking about generative AI, but is the key to how we interact with almost every generative AI model. So specifically, why prompt engineering makes a huge difference. But what is prompt engineering, right? So when we talk about it, what are the different parts of it? Does anybody out there really know what the different parts of a prompt are? Yeah, see? It's a wide topic that not a lot of people really know how to dive into. But what we'll talk about today is some of the best practices around balance, context, and refinement. So let's look at this a little closer. So firstly, what are the different parts of the prompt? The first is your context. So this is the kind of the business case. What is it you're doing with this AI model? What does the model need to know about your business, your operations? This is any background information that sets the stage for that task. Relevant constraints. Now, when we talk about constraints, we will have a separate section for specific constraints, but what we're talking about here with these kind of constraints are your context-focused constraints, and the most simple of that is the role. When we talk about role, are we talking, should the model look at it from a business analyst point of view, as a marketing point of view? So how should the model be looking at your data and looking at your context? So that's one simple constraint. Instructions, specific tasks that you want the AI to do. Clear and concise directions that tell it exactly what you're asking of it. And then finally, the actual constraints, right? Is there limitations to the size of the data set that you want it to respond back? And we'll look at this as an actual example in just a moment. Other parts of the context, or parts of the prompt that you want to look at, what are the input data, the very specific metrics, topology, any kind of data analysis that you want it to look at. And then finally, your final output format. How do you want it to organize all of this output data so that way you get a solid contextual response back? And there's a lot of trial and error in this, but let's look specifically at one of these examples. So as a context, technology copywriter, right? One of our role constraints. For Cosmonet Solutions, a pioneering company specializing in satellite-based internet, right? So this is the start of our context that the model is going to take in. What are the instructions we're asking it to do? Write a promotional blog to introduce Global Connect service, right, to potential customers. Our input data. So who's our company? What's our service? What's the monthly cost of this service? So this is all leading into input data that the model's going to take into account. Output format. What do I want? Attention-grabbing paragraphs, right? Or attention-grabbing headlines. Introduction paragraphs. I want 3 to 4 bullet points. So this is really diving into how we're structuring this so it's going to give us better and better results. And then finally, what are our end constraints, right? So it's a blog post, 400 to 500 words, using professional yet exciting tone, and finally, avoiding technical jargon, right? Because as a technology copywriter, we don't want it to be laced with jargon. So we're looking at this from a textual concept, so that way when we get into the image analysis and we start looking at some of these for how we would apply this to image analysis, you can kind of see the parallels between text-based LLMs and image analysis / geospatial LLMs. So with that, I'm going to turn it over to Joy, who's going to take us through some core examples for image analysis.
Awesome. Thanks, Chris. All right. Hello. Thanks again, everybody, for being here. And like Chris said, I hope you're having a great reInvent. So my name is Joy, and I'm a Principal Solutions Architect with Chris for our Aerospace and Satellite team. And so, as we started thinking about these problems of prompt refinement, the demos that I've built to show you, we're actually going to use satellite imagery, and we're going to show you how prompt refinement with Bedrock can get you better and better results as it pertains to a real interest area of ours, which is satellite imagery. However, before we jump into the demos, we just want to give you a little bit of context, right, around where we're at in the AWS generative AI stack. So, we've got 3 levels to our stack that we provide to our customers that gives all of our customers a lot of flexibility of how they can build their own generative AI applications. We've got, at our base level, we've got hardware, we've got training instances where if you're training your own very large model, this is where you're going to kind of fall in this stack. Now, obviously, I've been off in a different area, and I did not get to hear Swami's keynote. So my guess is that there were maybe some announcements that we're going to have to change this slide pretty soon. But in general, this is what we have for you. We've got the top, middle, and bottom, and the bottom's your kind of hardware stack. The top of your stack is your business applications like Amazon Q, right? These are things where, as democratized capabilities are presented to users for using generative AI, using Amazon Q, Q Developer, things like that. Where we're at in this demonstration, and where we want to show you some of the benefits of how to refine prompts to ask questions, is we're in the middle with Bedrock. So we are using, for this set of demonstrations, we're using Amazon Claude 3.5. And so Claude 3.5 is a really interesting model that does both text and image. So you can feed it images, for instance, and then you can ask Claude 3.5 to generate some text for you, like describe this image. So it's a very interesting use case. It has a lot of applicability across a lot of different areas of industries, right? So from a marketing standpoint, one of the big uses for this kind of image analysis and image generation is feed it a bunch of catalog images, right? Let's say I'm selling cat toys on the internet, and I can feed it pictures of all my cat toys, and I can tell it, hey, generate me a bunch of descriptions that I can use for my website so I can sell my cat toys. So that's these are the different models and the evolution of Claude and those models. So 3.5 Sonnet is the one that we used for this demonstration. All right, so time for the demo. Let's see how this works. Now, I will show you at the end, we're going to have a QR code. The code for this demo is on our open source GitHub repository of Amazon Bedrock samples. So we'll show it to you at the end. I built this all with stuff that's in our GitHub repo, and we'll do some demos here. All right, so this is the application that I built from that repo. It's just doing an image analysis with Claude Sonnet. I can point it to a particular model. I pointed it to 3.5. All right, let's start running through this demo. So you just pick an image, right? And this is going to be the base, kind of our base case. We're not going to give it any prompt at all. We're going to tell this model, just analyze this image. Tell me what it is. And like I said, since we're in the aerospace and satellite world, we think a lot about satellite imagery, satellite data, how to process that data, and just basically work with it faster. This is a picture, a satellite high-res picture of the coast of Western Australia. So you can see when it came back, it gave me a very detailed response of what it sees in that image. It's formatted in JSON. That was its default. I didn't tell it to do that. That's just what it does naturally. And so it gives me all sorts of information. This is a coastal area. There's vegetation. There's some structures that I see. There's some roads. That's pretty interesting, right? But maybe that's not really what I need. Interesting, but not my use case. So let's refine that prompt. Per what Chris said, let's give it a little background to work with. So what we're going to tell the model now is we're going to give it a couple of different things, and we're going to paste it into that top area. We're going to give it some context. We're going to tell it, hey, your role is that of a satellite imagery analyst, and we're going to give it instructions. We're going to get specific with it. We're going to tell the model, we want you to analyze this area of the coast of Western Australia, and we're giving it a goal, right? We want you to predict what might happen if there's a 10-foot storm surge in this area. We want it to limit itself to just 5 paragraphs of text. And, with a use case of urban planning, somebody that's never been to this area before, what can they find out about that from this satellite image? So let's see how this works. All right, so second iteration of the demo, right? We've refined the prompt with that context, those instructions. We're pasting those into that top area there, and you can see we've just copied and pasted that directly into the box. And we are going to tell Claude Sonnet 3.5, we're going to tell it to analyze that image. I'm using the same image just so you can have that comparison. All right, so scroll down here, you're going to get a picture of kind of what's in that image. And if you choose to pick the source code up, run it yourself, you'll see when it's actually running the model, you get the little icon up at the top, and it tells you it's working, it tells you it's running. All right, so it still spits out a little bit of JSON data. I didn't tell it not to do that, but now it's put itself in a particular role. It's like, oh, I'm a satellite imagery analyst, and I'm going to give you 5 paragraphs, and I'm going to predict for you what might happen if there's a 10-foot storm surge in this area. Urban planners, they might want to consider some things when they look at this. So it basically followed my instructions. It took on that role, it took on that persona, and it spit out those instructions. So super interesting. But let's say, we know a bit about actually analyzing satellite imagery, and that's nice. However, there's some constraints. The model probably shouldn't really do a legit prediction with just a flat satellite image, because there are these things called digital elevation models, and they tell you, it's basically a terrain map, and it knows better, maybe that's a cliff, right? And maybe a 10-foot storm surge, that's not actually going to do anything. So we are going to give the model some constraints. Another thing that we know about satellite image analysis is if there's significant cloud cover over a particular satellite image, that makes it less useful, right? That makes those predictions and those model image to text analysis a little less refined. So we want the model to tell us how much cloud cover is there. If there's more than 25%, warn us, right? Tell us this is going to require some human validation to go to this image and look at it and see if it's really making an accurate prediction here or not. But I can also tell it, okay, yeah, but please don't stop, right? Even if there's more than 25% cloud cover, go ahead, give me those 5 paragraphs, but just warn me that we should have a human take a look at this. All right, so we'll run through the demo a third time here, and this is our second prompt refinement. Remember, so we've done our role, we've done our instructions, and now we've given it some constraints. So we've given all 3 of those things. And I like it that with Chris's example, we actually told the model with the word constraints, it knows then, right? It knows, oh, this is a guardrail around what I should or should not do with this analysis. So same image, still the coast of Western Australia. And we run through the model, let it do its work here. Again, it still spits out some JSON, still is giving me those 5 paragraphs. But very interesting this time. Now it's telling me, yeah, you know what? There's about 40 to 50% of the image is cloud covered. And I was impressed with that. It actually did a very good job at estimating how much cloud cover was over that image. I thought that was really nice. It's told us we need to human validate this. And it's also told us we need to bring in a digital elevation model to validate that prediction of exactly what might happen with a 10-foot storm surge here in this area. So with that, those are the those are the 3 demos that we have prepared for you. We do have the 2 QR codes for you all. The first one takes you to our documentation. It runs through a lot of what Chris presented in even more detail. There are actually a lot of scientific research papers about prompt engineering and different styles of prompt engineering you can read about. You can adapt to your own use cases. You can learn more about inputs and roles and constraints. That bottom QR code takes you to a large body on GitHub of Bedrock sample code, which did include this image analysis that we showed you today. I'm personally eager to try this with Nova, right? The new announcements of our new models that came out yesterday. I want to see what it does with Nova, so that's going to be my homework project, I think, to do next. And like Chris mentioned, we're pretty close on time, so we'll be over here on this side. If you have questions, we'll just hang out, let us know, be happy to chat with you. We are also, again, the aerospace and satellite team, we have a booth just right over here in AWS Industries Pavilion under the public sector sign, so come see us and our team. And with that, we want to thank you for your time and attention. Please fill out the session survey, let us know how we did. Thank you.
Thank you.